Let us look at how variables work. So with assembly, the concept of variables doesn't really exist. All you're given is basically a bunch of locations in memory where you can store data, take it out, and manipulate it. So for example, you stored the number 27 in location 5 for some reason. If you want to add 1 to it, you basically take it out, give it some operation that says to add 1, you get 28, and so you stuff it back in and tell it to put it at location number 5. Or you can just put it at location number 7 and put it at 28 here. So essentially, 27 is the data that is stored, 5 is the location, and that's basically all you have to work with. This is a very simple example. Of course, everything varies depending on assembly languages, and some are pretty complicated and give you a little bit more than this. But essentially, this is how all data and calculations are stored at the lowest layer. So C is basically the next level up in the layers of abstraction. So now you can actually declare variables like int x equals to 2, for example. And what it does is basically it finds somewhere in memory that you can store the value 2 in. So it basically stores 2, and x kind of keeps track of the location 5, or basically the place where 2 is stored. So of course, if you say you access the variable x somewhere else, maybe in like an expression x plus 1 or whatever, what it does is basically goes to the location 5, finds the value 2, and then adds that with, for example, with 1. However, what you can also do is you can actually get the location in which it is stored. So if you append an ampersand in the front of the variable name, or what this gives you now is instead of 2, it actually gives you 5, or basically the address of where it is. You can also create something to store that address by using basically a pointer. So what you do is basically make an asterisk, and then you make the variable name, for example, right? So that you can set it to be equal to the address of x. So now pointer itself will store the location of 5. Why this is useful is because you can also get the value 2 from the pointer. So you basically ask it what is the value stored at location 5 by saying pointer, and this is basically the equivalent of writing x, and this will also give you 2. So let me give you an example. If you say we create a new integer like y equals to x, what it's doing is basically it's finding x, which is at location 5, and it finds 2 and sets y equals to 2. This basically stores y in some other location, let's say 7, and now of course if you say y equals to 1, it just changes it here to 1 and leaves x unchanged. So x as of current will still be 2. So of course, if you pass x into a function, the same thing will happen. The value inside the function will not change the value outside. However, if you were to use a pointer, right, like before we did, pointer equals to the address of x, what you're doing is basically, storing the location of 5. So if you set the pointer to be 1, it will actually change the value of x. So if you print x, it will give you 1 now. And this, you can also pass in the pointer because it's just a location to, for example, another function. And if you change that from within the function, it's still changing it at the location of 5, and it will change the value of x itself, actually. So basically, yeah, pointers is the place where it is stored, and this is the value that is actually there. Now, skipping to a language like JavaScript, you can still define variables in basically the same way for x equals to 2, for example. However, it doesn't let you find the location or the address of x, but you can still it still works the same way under the surface. And this kind of explains when stuff are referenced and when stuff is passed by value or copied. So let's say you have x, right? And then you say var y equals to x, like we did before. Of course, if you change y, it will not change x. However, if you were to change x to be an array or an object, like this, right? So now y is x, y, for example, you change the item in the array, y0 equals to 5, and when you print x, x will also actually be 5 to 3. So what is happening is basically these two values or these two variables are actually pointing or like it is referencing the same object or array. So what is happening is basically x should gives you a reference to the array, and when you pass in x, it doesn't actually make a copy of the array, so it is not the same as just making a new array like this. What is happening is it's just passing in basically where the array is stored to y. So basically they're accessing the same position in memory. So now when you change y, or change basically part of the array, it will also change x. Or if you were to do something like, for example, y equals to 2, x is still the array, because now you're just completely giving y a new value. It's not overwriting the array itself. So basically for stuff like integers, booleans, or strings, the value itself is passed to the new variable. However, with stuff like objects, you can think of it as like you're passing in the reference, so that basically two variables that are assigned like this will just share the same reference to the same object, so that when you change one, the other one changes. But in another sense, you can think of it as everything is passed by value, because it just happens that the value for an array is just the location of the array, not the array itself.